So previously you guys saw what is work done in terms of kinetic energy and what is work done in terms of potential energy, right? And you guys also saw that half mv square and mgh both are one and the same. Now, what exactly do you mean by kinetic energy and potential energy are the same? Because whatever we have learned is that kinetic energy is by the virtue of motion, whereas potential energy is the virtue of its position. How can these two be the same? So what we have is mechanical energy. Okay, so mechanical energy is kinetic energy plus potential energy. Okay, so what you guys will be learning is at any point of time for any object, the mechanical energy is always constant, meaning the sum of kinetic and potential energy is always the same. So this is what we are going to prove now. Okay, see, work done, when you take the work done formula, so W is equal to integral of f dx from x1 to x2, right? So this is the general formula. Now, this is nothing but the change in the kinetic energy, the work energy theorem. So we have W is equal to K2 minus K1, the final kinetic energy and the initial kinetic energy. And just now we also did one more formula, that is F is equal to minus dV by dx, correct? So we substitute that in the formula. So we get integral of minus dV by dx into dx from x1 to x2. Now dx gets cancelled. So we just have minus integral of dV from x1 to x2. Now dV, if you integrate, you get V. So we have negative V from x1 to x2, right? So if you substitute that, see, potential at that particular point you are calculating, right? So we have minus of V of x2 minus V of x1. That is the potential at x2, potential at x1. Okay. Now we'll call that as V2 and V1 for simplicity. So we have negative of V2 minus V1. That's nothing but V1 minus V2, right? So we have work done as V1 minus V2. So what we get here, we have W is equal to K2 minus K1 and W is also equal to V1 minus V2, right? So equate these two, that is K2 minus K1 is equal to V1 minus V2. In other words, K1 plus V1 is equal to K2 plus V2, correct? So the kinetic energy plus the potential energy in the first state is equal to kinetic energy plus potential energy at the second state. So if you generalize this, we can say K plus V is equal to constant. That means irrespective of which position you are in, the sum of kinetic and potential energy, they are the same. Okay. So this plays a very important part, because wherever we see, let's say an object is moving, an object is falling to the ground. At every point, the energy will remain the same. The kinetic energy can increase, potential will decrease. If potential is increasing, then kinetic energy will decrease. So how exactly that happens, you're going to see in the next video.